All right. We're going to continue with 5.2 today. If two triangles or figures are congruent, then what we said yesterday is all the parts of those two must be congruent as well. Okay, so for instance, if I have a triangle and I say these two triangles are congruent, how many pieces are we going to have to prove congruent if I have two triangles? 6, right? Because in a triangle we have sides and we have angles, right? So we have 3 sides and we have 3 angles. So in order for two triangles to be congruent, all 3 pairs of sides and all 3 pairs of angles must be congruent. If I had a 4-sided figure, we would have to prove 8 pieces congruent, right? Because we would have 4 sides and 4 angles. So we're going to see that a little bit today, where we're going to have to prove things congruent. So we're going to get back into proofs just a little bit today. These 3 properties right here should look familiar to you because we've talked about them already. The only difference here is that we're talking about them with triangles and not, when we saw these earlier in the semester, we talked about it with sides or angles or other things. Now we're saying if triangle ABC is congruent to triangle ABC, because it's the same triangle, right? The 2 triangles are congruent because it's the exact same triangle. So obviously it has to be congruent. So the easiest way to identify reflexive is the same statement. It's exactly the same thing. The 2 things must be congruent because they're the same figure. If I say ABC is congruent to DEF, somebody else could say DEF is congruent to ABC, and guess what? We're saying the same thing. We're just doing it in a different order. So the only thing that happens here is it switches sides. The symmetric property. If I said x equals 2 and somebody else says 2 equals x, we're saying the same thing, right? Same thing with these 2 triangles. If I have these 2 triangles and I know they're congruent, the order doesn't necessarily matter. Which one comes first and which one comes second. Okay, transitive, we talked about this one early on. 2 statements together will make a third statement. So we're going to combine 2 statements to make a third statement. Those 2 statements that we start with have to have something in common. In this case, they're both congruent to DEF. And because they're both congruent to DEF, then they're congruent to each other. ABC is congruent to DEF, DEF is congruent to JKL, therefore ABC is congruent to JKL. So they have a common piece between them. They're both congruent to DEF, so therefore they're congruent to each other. Okay, as we look at these 3 statements down here, trying to decide which one is which, all you have to ask yourself is what's happening. MNP is congruent to QRS, then QRS is congruent to MNP. What did we do? What changed in the statement? They switched, okay? So when they switch sides, then that would be symmetric. It's saying the exact same thing, right? Just saying it in a different order. JKL is congruent to MNO. MNO is congruent to PQR. Therefore, JKL is congruent to PQR. Two statements combine to make a third, different statement. And the last one, this should be the easiest of them all. Triangle XYZ is congruent to triangle XYZ. Reflexive. It's exactly the same statement. There's nothing different about those 2 triangles. Reflexive. Okay. Way back when we talked about it, we talked about looking at ourselves in the mirror and getting a reflection. It's the exact same image that we get when we look at the mirror. All right, so on this one down here, we don't necessarily have to write a 2-column proof, but we are going to have to prove that these 2 are or are not congruent. So we got this person that is painting the wall, and it's kind of weird because they're splitting their wall, not right down the middle, but with a diagonal down the middle. And I would say these people are some pretty good people because they're painting their wall orange and blue, so they must be some Broncos fans. So I would say, hey, these are some pretty good people right here. You don't agree? So we have these two figures, and what I'm going to do here is I'm going to redraw these two, just so we can look at them individually. Okay, this one here is AJKD. This one here is JBCK. Okay, these are the two that we're trying to prove congruent. And as we talked about here just a few minutes ago, in order for these two sections to be congruent, all the pieces of these two must be congruent. Well, the good news is some of the stuff is already labeled, right? So as I look at this, AJ and KC are marked the same. They're congruent. JB and KD have the same markings. So we know they're congruent. BC is congruent to AD. They're congruent. Let's focus on sides right now, and then we'll go to angles. We need the fourth side. Can we prove the fourth side's congruent? They're not marked right now. Okay. What do I notice about these two figures in the fourth side that's missing? Liana? Four sides the same thing. That's right. Okay. So here's what we could do, is we could say JK is congruent to JK. There's where the reflexive property kind of comes in. It's two different figures, but are we talking about the same exact side? Yeah, right? So we know it must be congruent because it's the exact same side. And so what's my reasoning there? It's just the good old reflexive property. Okay, so we have all four sides that are congruent. So that's the first thing that we have to do. Okay, angles. I know that angle A, angle D, angle B, and angle C are all 90-degree angles. That's already marked. Okay? I have to prove angles 1, 2, 3, and 4 are somehow congruent. Okay? Now, if I just look at it, 2 is acute, 1 is obtuse, 4 is obtuse, 3 is acute. So what would angle 2 have to be congruent to? 3. Right now, we don't know if they are or not. Okay? There's no marking. We have to prove that 2 is congruent to 3 and 1 is congruent to 4. What would I need in order to prove that? Do what? To find the angle. Okay, we could find the angle. Okay.
The top line and the bottom line are congruent. Oh, parallel.
Okay, do we know that for sure?
Yeah, because the right angle.
Okay, that's right. So if these two are right angles, then that means AB must be parallel to DC because they are perpendicular to BC. If two lines are perpendicular to the same line, then they are parallel to one another. The name of that theorem was the perpendicular transversal theorem. I don't necessarily ask you to remember the name of the theorem because we've talked about a lot of theorems this year. So that's why I would rather just write out the reasoning as to why. And if you said the perpendicular transversal theorem, that would be okay, but I think it's easier just to identify why. Okay? We did not have an arrow here, but we now know that these two are parallel. Okay? If I had arrows to begin with, then I wouldn't have had to prove that, but I needed to prove that. Okay? So now why are angle 2 and angle 3 congruent? Alternate interior. Good. Okay? So angle 2 is congruent to angle 3, and angle 1 is congruent to angle 4 by alternate interior angles. Because we proved the lines are parallel. Okay, so we've now proven that all sides and all angles are congruent, right? So what I'm going to do, I'm going to show you this, and we talked about this yesterday. Congruence statement. I'm going to start with the figure on the left. It doesn't really matter what letter you start with. I'm going to start with A in the top left, and I'm going to go around it clockwise. AJKD, okay? And we're going to say AJKD. But now here's the part we got to be really, really careful with. What is going to match with A? C. Okay. What's going to match with J? Okay. And all we're doing here is if I start at C, and if I move clockwise around here, CK, JB. Okay. And I'm going to tell you this over and over again. Order matters when we name these things, okay? If you just name it in any random order you want to name it in, then it's probably not going to be correct, okay? Unless you get lucky and actually happen to do it the right way, okay? A has to match with C. J has to match with K, because those are the two angles that were congruent. K has to match with J, and D has to match with B. Okay, so just be careful of the order that you put your letters in. That's the part you have to really be careful of. All right. This one here is asking us, are these two triangles congruent? Based on what we just talked about, all 6 pieces, we have 2 triangles, so all 6 pieces of these 2 triangles must be congruent. Okay? Do we already know the sides? Yeah, okay? So all sides are congruent. We can just say all sides are marked. Okay, none of the angles are marked though. So we have to be able to prove they're congruent in order to say they're congruent. What would be the easiest angle to prove here? If 2 triangles meet at a point, what can they? Vertical angles, okay? Remember here, we can't just call this angle T because there's a couple angle T's here. So I'm going to say angle PTS is congruent to angle RTQ by vertical angles. All vertical angles are congruent. So that one I had to use 3 letters. I don't necessarily have to use 3 letters here because this is the only angle at S. This is the only angle at Q, R, and P. So on the rest of these, I can just use 1 letter. What would S be congruent to? Q. How come?
Also, if you flip it and it like lines up.
Do we know the measure of it though? Can we prove that they have the same measure? Yeah. What else is on this picture that we haven't talked about yet? An arrow, right? They're parallel. We got an arrow on here. So PS and QR are parallel, right? And so what kind of angles would S and Q be? Alternate interior. Yeah. Okay. S and Q. And angle P and R are congruent by alternate interior angles. So we would say yes. Triangle PTS is congruent to triangle RTQ. Because all parts are congruent. What I will tell you is, as we go throughout this chapter, we won't have to do all 6 parts. Doing all 6 parts is pretty cumbersome. It takes us a while to get there. Later on in the chapter, we're going to find out easier ways to prove that these triangles are congruent, and doesn't take quite as much information to do that. Okay, another theorem. The third angle theorem. If I have 2 triangles, if this is 40 and this is 50, and this triangle has angles of 40 and 50, then what would the measure of the third angle have to be? 90. Okay? On both of them, right? So if I give you the first 2, the third has to be congruent. If the 2 triangles have 2 angles that are congruent, the third must be congruent as well. Okay? Now, we talked about this last chapter when we talked about dilations, and this is an important part. Let's use some different numbers here. Okay, if I give you these 2 right here, and it may not look like that's 100, but go with it, right? If I tell you that these are 40 and 100, okay, what would the third angle have to be? 40, okay? Are these 2 triangles the same size? No, they don't have to be the same size, okay? When 2 triangles have the same angle measures, they do not have to be the same size, okay? So don't automatically think that means these triangles are congruent. They could be, but they don't have to be, okay? And so in this case, that would be the third angle theorem again, is that the third angle is congruent, but that doesn't necessarily mean the triangles are congruent. Okay, on this one down here, I'm going to redraw these 2 triangles because I think it makes it a little bit easier to see. They're overlapping each other, which makes it a little bit more difficult. This is ADC. This one is BCD. Those 2 are marked congruent. And we know this one is 30. ADC is 30. So what does BCD have to be? 30, okay. Angle A is 45. And since this one has the same marking, this one also must be 45. So if I wanted to find BDC, this one down here, and I know the other 2 angles, how many degrees are in a triangle? 180, right? So 180 minus 30 minus 45. We're left with 105. Okay. The third angle must be 105. Okay. The third angle over here would also be 105. It doesn't ask me to find it. It doesn't ask me to find ACD, but if I had to, I could, because it would be the same measure. All right, this one down here. Angle R is 75. I don't know the measure of these 2 angles, okay? And I don't really want to, I could find this measure here, right? Because if this is 68 and this is 75, what would be the measure of that angle? What is the measure of angle R in S? Okay. So if S is 68, D would also be 68. So what does C have to be? 75. And you could call it DCN, but I'm just going to call it angle C because it's the only angle at C. So I don't really need to call it DCN. DCN has to be 75 because it's the same as angle R. Okay. Now, we're going to take this same picture, and if you look at the next, remember what we talked about here? These two triangles have the same angle measures. Were they necessarily congruent? No. So is just knowing the angles enough? Not enough, right? Knowing the angles are congruent is good information, but it's not quite enough. Page. It's the same problem again, okay? And what we just talked about, we know that angle D is equal to angle S, which is equal to 68. We know that angle C is equal to angle R, which is equal to 75. Okay, and then we know that the two angle ends are congruent. So we have all three angles are congruent. So is all, what's that? Oh, angle R twice, thank you. Angle R is congruent to angle C. Okay, and we know the two angle ends are congruent. Okay, so knowing that all three angles are congruent, is that enough to prove that these two triangles are congruent? Okay, right now, we would need to prove all of these sides are congruent. Right now, we only know one pair of sides is congruent. Is there anything that we know or can use to prove that these are congruent? Like, for instance, what would DN have to be congruent to? SN, okay? Is there any way to prove that DN and SN are congruent? No, okay? If I knew that N was the midpoint, then I could do that, right? If I said N is the midpoint, then I could say DN and SN are congruent. I don't know that, okay? Looks like it could be, but I can't just assume that to be true. Do I know that RS and DC are congruent? No. Looks like they could be. Maybe, right? We just don't have any way of proving that. There's nothing right now that we know about this that we could prove this to be true. So, what we're going to say here is we still need DC to be congruent to RS. And we also need DN to be congruent to SN. It says, what additional information do we need to conclude that those two triangles are congruent? These are the two pieces of information we would still need. And right now, there's no way to do that. We would need more information. So right now, we would have to say, we don't know if these two triangles are congruent. Maybe they are, but we don't have any way of proving it, okay? And so that's the part that gets a little bit tricky. All right, we haven't seen one of these for a while. Good old two-column proof, you know? Just when you think you're done with them, here they come back. Favorite thing, right, Tristan? No? Oh, I could have swore you told me that not too long ago. No? I must have been dreaming it, huh? Okay, two-column proof. First step in a two-column proof is always what? Given, okay? A lot of times the given information is stated to us, but they don't necessarily state it here. But we have some stuff that's marked on the picture, okay? And some people like to do this, and it's kind of up to you if you're that kind of person that needs to see kind of a visual. These are the two triangles that we're talking to. All I did here was just separate the two triangles. We're trying to prove that these two triangles are congruent, okay? So by separating it, maybe that helps a little bit to be able to see the two triangles that we're looking at. Okay, first of all, AD and BC are marked congruent. That is one way to give or provide information because it's marked, okay? It doesn't actually come out and say that, but it's marked. So that is given information. We have lots of given information here. I'm going to put all of that on step one. There's no reason to write it as a bunch of individual steps. We also know that AB and CD are congruent. Okay, what else? Okay, what would I call this angle right here? Can I just call it angle A? No, because we have two angle A's. So how could I name that angle? Yeah, so I could either go DAC or CAD. Either one of those would be fine. So I'm going to go angle ADC, or sorry, DAC is congruent to, and it's congruent to this angle down here. So we would call that BCA. And then we also have these two angles that are marked. So we're going to say angle DCA is congruent to angle BAC. Okay, how many pieces do we have congruent right now? 4. How many do we need? How many total do we need?
8.
What kind of figures do we have?
6.
We have triangles, right? So if we have 2 triangles, we have 3 angles and we have 3 sides that we need to prove congruent. So I need to prove the third side is congruent. I need to prove the third angle is congruent. Doesn't matter which one we start with. I got to prove all 6 pieces, okay? Look at these 2 sides. What do we notice?
They're both AC.
They're both AC, okay? So I can simply say AC is congruent to AC. How would we know that AC is congruent to AC? It's the same thing. What do we call that? Reflexive, because it's the exact same statement. So there's the reflexive property again. Okay, then I'm going to go ahead and mark it. So now we got 5 pieces. We got 3 sides. I got 2 angles. I need 1 more pair of angles. Why would angle D be congruent to angle B? What do we have that we can use? Yeah, Venus?
You could do like the third angles theorem.
Perfect. Yeah, that new theorem we just learned today. If 2 angles are congruent on 2 triangles, then the third angle must be congruent as well. And we don't even know the measures of those angles, but because 2 are congruent, we know the third one must be as well. Okay, and therefore, we now have all 6 pieces. So my final statement, okay, and what I'm going to tell you is make it as simple as you can. This one gives me the statement right here. Just use that, okay? There's no sense in you trying to come up with it on your own. Just restate triangle ACD is congruent to triangle CAB because all corresponding parts are congruent. All 6 pieces are congruent. It's not really a theorem, but we just have to prove all the parts before we can say they're congruent. Okay.